container as container for resources like the system, network. Oh, I have not started the recording, is it?
I have started the recording, but the issue is I think you have a little bad internet connections for today. Maybe
Maybe.
guys, is it only
Is it?
me or everyone seeing some video
It's not
or
Yeah,
only
it's
you.
same for me
The
too.
voice is not
We are
being
having
clear.
the same technical challenge.
yeah, maybe we can stop the video.
We can stop the
Yeah,
video.
okay.
Yes, video is not very important. Yeah, I think it is too much. It is very hot over in India and there is some issue of the power networking. So let me stop this video if that helps. I'm not sure. So shall I turn on the recording?
The recording I have already, it is on.
Okay, it is already started. Yeah, fine. I will go back to my. Let me know where. Is it a bit clear?
No.
It's not clear, sir.
Not at all.
Now it is good.
Is the screen good now? Is it visible more or less?
No, screen is not visible. Okay, it is visible now.
Shall I reshare?
Yeah.
Let me reshare.
No, we can see your screen now.
Is it more or less clear now?
Yes.
Okay. Fine, that's good news. Let us proceed. See, these are the technical things. We do not have much things to do about it. Okay, fine. So you can see these three containers for the same environment. So what was happening before containerization? Is the screen clear now? Again, I'm just trying to reconfirm.
Yes.
Okay. So what was happening before containerization? Before Docker came into the market or before any containerization tool came into the market? You see, the development process before the containers were there. Say these are the developers. A developer is on Mac, a developer is on Linux, or a developer could be on Windows. So each developer needs to install and configure all the services directly on their OS, on their local machine. So the OS can differ. So the configuration and installation and the environment will differ. Okay, you have to do all this installation process different on each environment. So it is not, your environment is not portable. So some environment that you have built for your application on Mac is not compatible on Linux. So you have to do the reinstallation, rebuilding of your entire application. That takes a lot of effort and there could be lots of errors and you need some expert hand to mitigate that particular risk. And therefore you had many steps where something can go wrong very easily. If your app uses 10 services, each developers need to install all these 10 services. There is no shortcuts. And what about the deployment? The development, of course, was a bit difficult. What about the deployment? Was it very smooth? Let's see. So the developers working on various different environments was putting them into the operations. And these poor guys were struggling a lot to fit in that development, whatever the development, the application into their respective environments, because the development environment and the operations, because this is maybe a pre-production server, this may be a testing server, this may be a production server. So they will differ in exactly the the environment that they have employed, because the developers will tweak and tune their environment according to their requirement of the development. Okay. Whereas your operations guy has to have a common environment, because it is not only one project which is running. There are several more projects. And how will the operations guy keep on changing from environment to fit in various types of applications on different environments? Environment by environment, I mean the OS level, the application level, and the networking level. So many things are there to be taken into picture. So artifact and instructions handed over to the operations team. Operations team handles installation and configuring apps and its dependencies. There were lots of dependencies, and these guys were struggling a lot. Installations and configurations done directly on servers OS, dependency version conflicts, so many conflicts will be there. This led to a lot of confusion, because how the developers used to give the deployment instructions to can anybody tell me how will they hand over the deployment instructions to these guys, operation? They will document it over a textual guide. They have to follow step by step, but there would be a lot of confusion because they exactly do not know about the operations environment, and operations guys do not know about this development environment. So this textual guide is not enough. Finally, the development team and the operations team had to work together to work out on the environment. That was quite difficult. Now, what happened after containerization when Docker came into picture? What Docker did, let's say you have a configuration, you have a Postgres SQL, and you have a starting script. So these things are separate parts. So what Docker did was it isolated the environment from the application. That is the first thing. This is the application. This is the environment and the configuration. So they were isolated. So this is a single piece of object. This is a single piece of object. They do not interact, or rather clash, intersect. So the Postgres was packaged with Postgres means this is a database, SQL database. Postgres packaged with all dependencies and configuration. So you have a script where it's a Docker script or something like, you will have this configuration dependencies merged with the Postgres application. So you have built your own environment. You have isolated that environment from the rest of other things. So you start service as Docker container. You just use Docker command, not a lot of configurations. That the command will remain the same for all the single command. When you create a container, will remain the same whether you are using. My voice is breaking. Hello.
Yeah, it's better now, but during the lecture it is breaking.
Okay. So what to do about it? I mean,
now it's better.
Now it's better. Okay, thank you.
Sorry for interruption.
No, it's okay. I wouldn't know what is happening on the other end, so it's good that you informed. Now is it okay?
Again bad.
More or less. Again bad. I'm not sure what is happening today. Oh, this is Too bad. Okay, just give me 1 minute.
Hello.
Hey. Yeah.
Yes, like how can we find the recorded sessions?
Recorded session, normally we'll share the link in the group. If you are registered in our website, you will find the day wise recording on the in the very first lesson, inside the lesson.
Okay. I guess I'm not in the group. I'm like.
Are
Can
you
you
in
add me?
the are you in the uh, did you complete the registration?
Yes. Actually, I got your mail, but I'm not in a group where I can find the recorded sessions.
You can, if you are already registered, then you will find in the inside the course. If you click the continue button in the left side, you will find all the day-to-day course content and course
Okay,
curriculums,
I
right?
guess I've provided Gmail ID at the time of registration, and I have like connected with the Outlook ID. That's why.
Okay. Okay, I will share in the group, and you just ping us in a WhatsApp, because I don't know what is your number. So there is a bot. That bot will automatically share you a group link.
I'm not also in a WhatsApp group.
No, but do you have our WhatsApp number?
Yes.
Just ping it. There is a bot. It will share you the group link, and you just need to click it.
Okay, where like I can ping you?
In our WhatsApp number. Our WhatsApp number starting with just
Share me.
yeah.
Can I continue?
Yes.
Okay, because we can discuss this after the session is over. Is that
Okay.
fine?
Sure.
Is the voice a bit better now?
It's better.
Okay. Where were we? We were saying that, yeah. So one great advantage of using Docker is that I will be using one Docker command, and that Docker command will be applicable to all the OS, whether it is Mac, whether it is Windows, or whether it is Linux. And command will remain the same for all the services, not only for the creating the container, creating the image and all those stuff, but any of the services, whatever Docker commands we use are going to remain the same. That is a big advantage, you know. So what is happening is easy to run different versions of the same application without any conflict. So if you had some deployments over Redis 4.1 or Redis 4.3, Redis 3.9, you do not have to change any of your commands. The commands and the services remain the same. That is a big advantage. You just have to redeploy with the new version of the application. That's all. You do not have to reinstall. You do not have to recompile. You do not have to rebuild. That takes a lot. Yeah.
What is Redis?
Okay. You can just, for the timing, think of Redis as, a key value store. These key value stores are becoming very important nowadays when you are doing some serverless processing. Like Postgres SQL.
Okay, like a
What is that?
database.
Like a database,
Okay.
where it is a structured database where, you have the schemas, you have a framework, you cannot go beyond that frame. But did you hear about MongoDB?
Yes.
What is MongoDB? MongoDBs are no SQL database. That means those which can handle without any schema, without any SQLs. See, for SQLs, you need a structured database. That means some database with schemas. Those are called relational database management system, RDBMS. Whereas MongoDB are not, they do not go by the schema. That is very good for unstructured data. Unstructured data.
Sorry,
Yeah.
would you say Postgres is the same like Redis?
No, that is what I'm. Postgres is. You were asking about Postgres?
Yes.
Yeah, Postgres is an RDBMS. Redis is not an RDBMS. It is actually for serverless processing and for Lambda type of functions, which are very much important components of serverless processing, like stateless processing. Stateless. This is with the state. You have to persist the state. You have to know the state beforehand. The history of the state should be known to you before you make a fire and SQL query. Whereas for this, you do not need to worry about the state. These are all stateless processing. But I'm saying about our Redis is not the point of discussion here. What we are discussing that whether you change the versions, okay, it will not affect your deployment. You do not have to reinstall Redis. You do not have to reconfigure the environment for Redis, the higher version. OK, and you do not have to rebuild your application. Even for Postgres, you do not have to do it again and again. You simply use one Docker command, and that command will be valid for just for your deployment. You containerize it again. That's all. So the container will, as we have discussed, the container will have the entire environment within the container itself. So what you do, it's sort of a plug and play. You pick up a container from this environment, from the development environment, which is done on Linux, and you may put it on the operations teams Linux. It can be a pre-production environment or environment, and put it there. You do not have to change anything. You do not have to rebuild it. You do not have to reinstall it. You do not have to reconfigure the environment. That is a big headache. That headache gone. Deployment process with the containers. So you have a container with the jar file. The jar file means the Java file, Java application with all its dependencies. That is the bins and the libraries, along with the configuration. Whatever is needed, you pack up within the container. These are the developers. They will pack up the entire thing within the container, and the container will be going to using the Docker. You will be deploying it to any environment. Instead of textual instructions, everything is packaged inside the Docker artifact. Artifact means a particular, say a file. So you just have to deploy this file and you run this file. That's all. No configurations need on the server. You do not need to rebuild the configuration on the operations team server or the testing team server. But yeah, of course, you have to have the Docker runtime installed. That is one thing. That is one requirement. That's all. No room for errors. Less room, or basically no room for errors. You have reduced the error to 0 level. So install the Docker runtime on the server. Run Docker command to fetch and run the Docker artifacts. That's all. It is very simple. Since you do not have a view of how easy it is, when you learn Docker in details, you will understand that it is becoming too much easy to learn and implement Docker in any organization. So what was the problem before containerization? So I have a small little diagram to tell you, because these pictures tell you a lot of things. The problem was with the environment the code was being run in. As I'm saying again and again, saying environment is the enemy for the operations team. This operation team gets too much of a trouble with the environment to be set up, and the development team does not comply with the environment that needs to be done for the operations team. Well, a simple answer could be, why not give the same virtual machine to the operations testing to run the code. So they are saying, developers are saying, you are having a lot of problem with the environment. So why don't you take the entire VM from me and port it into your system? But that is not a possible solution. Well, try that VM virtual machine that I'm working in. It is very simple for the developer to tell so, but it is very difficult for the operations team to just port in that VM. It is not easy at all. So what he's saying, operations team is saying, that could break another code on the testing or production server or pre-production server. So it is developer, you must understand, it is not only your code or your environment that is I'm working with. I'm working with hundreds of other projects and environments, at least more than one. So I am not only working with your code, I'm working with so many other codes, so many other environments. So what happened after containerization? This was the scenario before the containerization. Now we come to the containerization. Is the voice okay, or is it still problem?
It is better. It's not in its good like its good days, but I think it is better than previous, right?
Okay. So fine. What we do is, hello. Hello.
I hear you.
Okay. So with containers, all the environment issues were resolved. The developer could easily wrap their code in a lightweight container. So container is an abstraction layer on top of the developer's code. Just a layer, like you are packaging it with an environment and shielding it from the distractions of other environments, so it can be isolated. Isolation is very important over here, and that can be achieved through containerization. And pass it on to the operations team. So you are passing the container to the operations team. Okay, the developer is saying, here is the container. I have wrapped my code in. So because I am not giving the virtual machine, so a virtual machine can be 2 or 3 GB for my application to just get inside that environment. I'm putting that in a virtual machine, and that virtual environment is itself 2 or 3 GB. How can you port in such a big one? But here, when I containerize it, it becomes very, very lightweight. We have seen in the previous slides. Wow, it's hardly 30 MB. It was 3 GB, and it has reduced to almost 100 times. It's hardly 30 MB. Awesome. So it's very easy. When you are traveling, is it not good to travel with when you are light in your packaging? You feel very light, very comfortable. Whereas when you travel with a huge baggage, very heavy baggage, the travel becomes a botheration. Similarly here, you think that instead of giving 3 GB to the operations team to fit into his environment, that person is giving only 30 MB, and the entire application is being packaged within 30 MB and being delivered to the operations team. So this life of this guy becomes good. The nightmares have gone.
Excuse me, sir. Hello.
Hello.
So this containerization is the advanced level of hypervisor, right?
Exactly, exactly. Very good. I mean, you have got the essence that we have stepped forward from virtualization into containerization. Because in the further slides, we will see why we left virtualization because of these problems, yes, and also for something else as well. We are coming to that slide.
So we can install, instead of normal VM, we can install Kubernetes in Docker, right?
Yeah. So Kubernetes is an orchestration tool. We will come to Kubernetes in our next session. 2 consecutive sessions on Kubernetes. We will understand the architecture where Docker fits in. Not only Docker, any containerization tool, whether it's Rocket or Mesos or Docker. But Docker is very popular, and many of the of your implementations come Docker inbuilt because you cannot avoid now without containerization. You cannot think of delivery and deployment and integration. So that is the reason. Because why? The question is why? Why we have moved into containerization? It is because the nature of our applications are transforming. The nature of our applications are transforming.
Hello, sir.
Hello.
What is the Docker artifacts?
Docker artifacts, we will come to that. Just give me some time. Sure.
Okay, fine.
But one question that I can ask you, by artifacts, do you understand what is artifacts? Why this term artifacts?
No, sir, I didn't understand. That's why I was asking.
No. I mean, say there is a very popular term called artifacts. Everyone is using this term artifacts. But if you ask anyone, sir, do you know what artifact is? Why we are always talking about artifacts? What is that? Is it a document?
It's
or
like
something else?
Logging, I think.
Sorry, can you come again?
It's for logging and like monitoring something.
That's good. That is one part of artifact. Yes, why not? Artifacts, we can say something which is your manifest files. You manifest because see, when you talk about DevOps, you talk about something of what. We are not discussing how. When we discuss what, that means you desire something, you want to have something, you desire something. So you declare it. When you declare it, those are declarative scripts, right? Those declarative scripts are manifest files, whether it's YAML files or something else. Those scripts are declarative scripts, and those are called artifacts. Are you getting me? So you are giving some instructions to either Docker, to Terraform, to Ansible, but through artifacts. So Docker has its own set of artifacts. We will come to that slide, okay?
Okay, sure.
Some set of instructions which are internally understood by that system. Those are artifacts of a system. Now, my basic question was, why was the need for the industry? Because there is an invention there when there is a need, and that need was to get away from virtualization and come to containerization. Why? Because our system was gradually changing. Our mode of application, the application nature of application was changing from monolithic architecture to the microservices architecture. Then what is the difference? So around starting from 2000 till date, this was a gradual transformation from monolithic towards microservice. Monolithic needs a huge elephant type of a server, big server. And you have one layer, monolithic. Mono means one and lithic means layer. It's a Greek word. Lithic is a Greek word. So mono means one and lithic one. So lithic means layer. So the entire application with the environment, with the dependencies, with the binaries, with the libraries, with the application, with the networking, with the OS kernel, everything was included into one big layer. One layer. So let's say this is a function. There are several functions constituting the entire application. OK. So let's say there are 10 functions, out of which this function has gone wrong. So can you take it out separately, rectify it and put it back? Is it possible in a monolithic one? Can anybody tell me? Let's say this part of the body, like you are a body, one single layer. So your head is spinning. So will you be able to take out your head, rectify, correct it, and put it back? So will your body function like that? No. So what you have to do is you have to shut down the entire, your body will shut down. So you have a fever, you cannot go to work because your nothing will work. Your legs, your hands, your chest, everything is paining. They are not in shape. So you have to shut down your body system. You have to lie down, take medicines, get well, and then only you will be okay. So it will take time to absorb that particular medicine. The medicine should work, and it will be then gradually your body will come into shape. Similarly, think of an application which is running in one layer where there are so many functions working together. If there is one function which is not working, so the entire application will go down just because one of the application not working. There is no way you can take out this application or this function separately, correct it and put it back. You have to shut down. You have to rectify this part. OK. And then you have to again rebuild the entire environment. You have to retest it and repackage it and then release it for production. So you have to do entire cycle again. It is very cumbersome. It is very time taking. It is very tedious. And it can be again, suppose you have rectified this. OK, when you have put it back, when you have recompiled, some of the functions which were correctly working was not working now. So because of one function getting rectified, other functions were impacted. So this was because they were very tightly coupled, very tightly coupled. Now, so the change is very slow. You cannot do it automatically. Whereas now think of today's applications. You talk about microservices, the same blue, green, some gray, all these things are separate functions, but they are now isolated. They are all working inside one container. These are all containers. And you can say this is one function as an image. This is one function as an image. One function as an image. So all these images are nothing but the applications or the functions, but they are separate entities now. They are not interacting or not interacting. They were not interfering with the function of this. So if this function goes wrong, what you do? You just take out, correct it, put it back. No other functions are getting impacted. That is the beauty. But with this large facility, with this huge facility comes the problem of maintenance. And if this function needs to talk to this function or this function, you have to know which service is calling which service for the help. Maybe this is the Java application, some function of Java application working here, and this is the login function of Java. This is the login database. Okay, this is the product catalog when you do the shopping, product catalog, and this is the product database. So they must be talking to each other as this microservice will talk to this one. Maybe when you are logging, you are just interacting with this database because that is the login database. So authentication, authorization will be happening between these two. They are not impacted. So they will be sprung into operation when you call for this service. So this is the entire, I'm saying, the usefulness of microservices. So instead of having a big server, and there is, when you go for a big server, there is always a possibility of that something or the other is going to go wrong. Maybe the hard disk will crash, or maybe the network, this part and that part is not working. The connectivity is not working properly. But here you can deploy your microservices all and with the replicas all over into smaller machines. And you can say this node 1, node 2, node 3, node 4, they are load balanced. There will be a load balancer to distribute the queries or the traffic between the servers. So your entire application is distributed all over the server. So the availability of your application rises. Can you understand what I'm trying to clear?
Yeah.
So if this server goes down, yeah, tell me.
Is a load balancer is a inbuilt in the server or will create a load balancer? It is inbuilt in the server, right?
Which one?
This load balancer, you speak about a load balancer, right? This load balancer is inbuilt in the server, or shall we create a load balancer for this?
It depends on the architect. If the architect says that I will go for a separate server in this cluster of machines, I will have one node which is dedicated for load balancing. So load balancing is a software. It's an architecture. OK, so that will be over into. There are so many types of load balancers in the market. One of the most popular load balancer, can you tell me?
Application gateway, F5 load balancer, right?
Yeah, there are many, but one of them is very popular is Nginx, a reverse proxy server, which is also a load balancer. We will learn about that when we come to Kubernetes, because this is an ideal use case for having an orchestration technology tool, because to maintain all this huge number of microservices takes a lot of, because one of the health of this pod or this particular container may go wrong. How will you know? So there must be somebody who is monitoring the health of the system. So this has given rise to a lot of complexity as well. Microservices are not very easy to design and maintain. But if it could be done, it is a great achievement. It will really leverage a lot of benefit for the company. Are you getting me? So you can say that since these microservices are all distributed, microservices are applications within the containers. So these are one containers. So many containers having one piece of image or microservice or application. So if you wanted to distribute it within say 4 servers, and there is a huge request coming, there is a huge this application is very popular, like e-commerce site. There can be millions of users accessing your application. So in that case, for distributing the huge load, you can have a dedicated server called load balancer. And that load balancer, so every request will hit the load balancer. OK, and the load balancer has the intelligence to distribute the queries or the requests to all of these servers, because you are accessing all the same application. but they are distributed all over. So there is a service discovery. There are lots of things. Because you went to a microservice application called e-commerce and you are looking for a product. Maybe I have gone into that same application, but I'm looking for, say, some other product, or maybe I am transacting, I'm paying for a order that I have booked. So my activity will be different from others' activity. So I am looking for a particular service. Maybe some other person is looking for this service, this service. So how will the service discovery happen? All these things will happen with some technology inside Kubernetes. But these are all Docker containers. We will understand that. But did you understand the utility, the usefulness of Docker? Transforming the entire way you think about deploying your applications and maintaining your applications, or containerizing your application. So this is the application modernization, where you have the application code with all its functions and environment, small bits, but in one layer, which was distributed. Now you have microservices. Each of the functions are one microservice. So the developer issues you have understood. I have already discussed that. So when you design, this is a very famous thing, like in Oracle, like in any RDBMS, there are 12 COD rules. COD, Mr. COD, who had given you the RDBMS rules, when a database can become an relational database. Similarly, if you want to design a microservice application, you have to bear in mind 12 factors. Okay, anyway, because we are not developers, we are DevOps guys. Just to know this is important for us. I do not have to do it. Okay, I was saying something called stateless, isn't it? Some lady asked me about that Redis. So this comes with the microservice, this scalability, statelessness, highly available. The design of microservice should cater to all these things. Okay. My voice still giving
Sir,
problems?
excuse me, quick question.
Yeah.
Do we have access to those slides after?
Yes.
Okay, thank you.
Same. As I'm telling you, since you are registered, you go to our site, you go to DevOps Program 1 or Program 2. Okay, you will get access to all this.
Thank you.
Slides, content, as well as the recording, as well as some questions to be prepared for your some quiz, so that you know where you stand. Because this is not a normal training session. It is just an awareness program, so that you grow that interest. You know what is what, and you know where do you stand, whether this will be applicable for your career. That's why we have that's why this has gone to this level. That means we're trying to help you understand whether you would like to go for learning this subject.
Very fantastic.
Hello. Sorry, my voice again. There is some issue, right?
Yes, you are breaking up when you are speaking.
I'm sorry, this is happening today. I don't know, some network issue.
It is not that bad.
Otherwise, the other 6 sessions were quite smooth. There was no issue, but today there are some electrical breakdown in our locality.
Devasis
There
is
were
better
a
than
few
the
power
beginning.
cuts.
Don't worry. Just don't worry. Move on. It's better than the beginning.
Forge ahead.
Oh, is it? Okay. So just bear with me. So application delivery, you see, this is one of the major bottlenecks of your projects. Most of the projects fail at this level, deployment and delivery. It took us such a long time and with such a big effort that either it exceeded the budget for the customer or by the customer, or it finally could not deliver the quality product. I'm saying about 10 years back when Docker was not there. But right now, Amazon in a day, they deploy almost like 15 to 16 deliveries or deployments in a day. It's a huge advantage to deliver 15 or 16 features. It will take maybe say 3 to 4 months in a normal when we were not talking about microservices, when we were not talking about, we were talking about monolithic, and we were talking about downtimes, and we were talking about one big server. The deployments were not blue-green deployments, or there was no rolling updates. So some issue here and there would happen. So it took a lot of time and a lot of expertise. But now, you see, from development to testing to the pre-production or to the production, this delivery so seamlessly and so automatically that it is quite astounding. You see, a developer will put in the code, the developed code into the version control. The version control with the pipeline, we have learned about GitLab. So the pipelines will be built between the developers, between the version control. The version control could be on the GitLab itself, and the pipeline will automatically build it. If there is in the build, it will go back to the developer through the pipeline. The developer will again correct it, put it back to the code. The change will trigger the pipeline. The pipeline will again it. So there will be a build. So that build server will build this, build and package. And once it is packaged, this can go.
Mr. Devashish, I think
The server.
Your voice is very now it is very bad.
Okay, just 1 minute.
I am assuming because of the your power issues, something is wrong with your internet connection as well. It is fluctuating.
Now you tell me.
It is better.
Is it better now?
Yes.
Okay, I am really sorry for this inconvenience. Shall I carry on?
Yeah. If we will make it short, today's session, until unless every other students they disagree with me and they want to continue, then that's fine.
See, my objective today is to I wanted to complete Docker, because then we can on the next weekend we can start with the Kubernetes. Unless I complete this today, I cannot start Kubernetes. So guys, what do you say?
In my opinion, I think we should just continue. If you break, you stop for maybe 30 seconds or something, readjust it, and then it will pick up.
Yeah, that is a good suggestion.
Okay, right. I will continue with all these disturbances. Let's continue and finish it up. So this could be a testing server. So there will be an auto deployment into the testing server, and the testing server is nothing but a QA server. QA. This testing team is under the quality assurance team, and the quality assurance team will be under the operations team. So operations team are the bigger picture, the development and operations. That's why you are a DevOps guy. You work with both the teams to help them automate their process from building, from development to from the inception to the deployment. So this server may be a test server, maybe a pre-production server, whatever it is. It can be on the cloud. It can be on premise. Okay, whatever it is. So you deploy it through the pipeline, automated pipeline. And these are all possible because you have one great friend of yours, which is called Docker. The containerization has made everything possible. Now today you can, within minutes, you can deploy from here to here. You can come. Okay. Any questions over here?
I think we
What
had
about
a,
this bit?
not exactly for this on this topic, but we have received a very interesting question from Joy. So Joyce, let me the question is, today I joined the class. Actually, I am interested to learn DevOps, but I heard DevOps will sustain for 2 to 3 years in the future. Could you enlighten on this, please?
Yeah.
Any thought?
Do you want to address that question from your business perspective, from the industry point of view?
Okay, so from my point of view, that is not right, because DevOps comes when the company try to automate their software development cycle and shorten their budget, shorten the manpower, and
Correct.
out of mostly 40% companies so far now fully integrate their DevOps on their productions or their development cycle. Now remain 60% remain. Now what will happen? The other 60%, when they have already integrate the DevOps, then DevOps will be closed, or the DevOps demand will be ended? Not at all, because all software or applications, the development never ended. It's always like, if you see Amazon or any, just check any of your applications on your mobile or on your computer, every now and then you'll receive update. So development never, until unless the development stop, DevOps will be there. Now DevOps will evolve. It will evolve in some other form. The form is SRE, Site Reliable Engineers. What is that? Now, once some company already integrate DevOps on their software development lifecycle, SDLC, now it's already there. Now they don't need to create new pipelines. The pipeline is already there. Then they need somebody who have a experience on SRE engineer. Now, what is SRE engineer? Now, their job will be to maintain the DevOps pipeline regular basis. So there should not be any vulnerability. There should not be any security gaps. There should not be breakdown. If there is any patches or upgradation is coming, that should be done regular basis. So DevOps engineers' main role right now is creating the pipelines or the flow to make sure the agile methodology, implement the agile methodology on development cycle. Now once that thing is done, then DevOps engineer will change, and their responsibility will be to maintain that infrastructure. So if somebody is saying that it will close after 2 to 3 years, that is solely wrong. It will this evolve. DevOps, I think, came in the picture 2014, and SRE came in the picture 2019.
Yeah, exactly.
And it is going parallelly, and it will go parallelly. So now just think like 5-10 years before, there is some positions name is Linux developer and system engineer. Then DevOps came. Now system engineer, Linux developer and DevOps role is fully different. But those people are that time working on Linux developer, they like shifted to DevOps because Linux is a base for DevOps. But DevOps and SRE is not like that. It is 60 to 70% is same. And to become a SRE engineer, you have to know your DevOps fundamental, or at least DevOps pipeline and good hands-on on that.
And not only that, it will be very difficult for you to upgrade to any cybersecurity and DevSecOps without a knowledge of DevOps. So yeah, you can go directly to cybersecurity without knowing DevOps, but at one stage you will yourself feel that you must have some feel of DevOps. So you will study at that level, without which you will not be a very good, security engineer.
Now in the market, every technology is started, then grow, then it reaches its peak, then it goes down. Okay, or some new technology replace it. In the industry, DevOps yet reach its peak, so it will grow another 5-6 years until unless at least 70-80% company implementing DevOps on their infrastructure.
Yeah, we had a slide on that the previous session that clearly indicated with the threat of AI as well, how it is predicted to grow till 2028.
Joy, is your question, you got your answer? Okay, I think we can continue with our Docker lecture.
So there is a bit of history of Docker. Am I being audible?
Yes.
So I will not go into that much of a history, but yes, you can say it came to the market 2013, and this guy, Solomon Hykes, was a very important guy who started everything with the help of Linux. Yes, Linux and Solaris. They were the system operating systems which helped the Solomon Hykes to think of coming out from virtualization and go for containerization. There are lots of contributors. It's a very hugely popular software. You see the adaptations, incredible adoption in just 4 years. And that is a statistics of 2020. So between 2017 to 2020, this has gone from here to here. And now almost every other software is coming with Docker inbuilt. Mostly the orchestration tools. So Docker is an open platform for developing, shipping, running applications. We have learned about this, yeah, in form of containerization. So Docker provides the ability to package and run an application in a loosely isolated environment called container. So you remember two things. Package is nothing but an image. Application is an image inside a container. We have run through this, those slides. The isolation and security allow you to run many containers simultaneously on a given host. That is very important term called isolation. Your microservice, your container should be self-sufficient to run solo, and that the container should be able to be secured. And Docker gives you that environment. Containers are lightweight because they don't need the extra load of a hypervisor, but run directly without the host machine's kernel. This is kernel takes almost 70% of your memory space and the disk space. So my container does not have the kernel. It has only the binaries and libraries for the required dependencies. This means you can run more and more containers on a given hardware combination than if you were using virtual machines. We have discussed all these things. So a Docker engine architecture. You see, the architecture is very simple. On top, when you interact, you as a user, you will be interacting with the network and you will get inside this shell of Docker. On the outer layer is the Docker CLI, Docker command line interface, where you will run the Docker commands. So that Docker command will be internal. See, this is entirely an API based, and the REST API, you know what is REST API? It's a very important term. Please, I will suggest everyone to go to the internet, to go to Google and find out what is REST API. Because the world is moving as you are more and more going towards, service oriented queries. That means you are going to look for a service through some APIs. And there comes the importance of REST APIs. Because there are so many services in that environment that it will be lost in the mesh. So there is a service mesh which will help you to reach you to that destination in the shortest possible manner, in the shortest possible time. And the REST API does the main function with it. So you are firing a Docker command. That command will be gone to the REST API, and the REST API will convert that command to the Docker kernel, which is called the Docker daemon. This is the Docker engine. So you cannot directly access, you cannot directly go to the Docker daemon. That is secured. And the Docker daemon, once it comes with a filtered query through the REST API and through the Docker CLI, will then be able to manage the network, manage the Docker volumes, manage the images, manage the containers. Everything is being done by the Docker daemon, but you are giving the commands. You are giving the commands, the declarations. There comes the artifacts. Somebody was asking about artifacts. Here you place your artifact, your instructions, and that will flow down to the REST API, and the REST API will send it to the Docker daemon in its particular language, which it can know, and thereafter it can manage very easily the storage, the network, the container, the image inside the container. What else do you want? So simple an architecture. So a server, which is a type of long running program called daemon process. So this is the daemon process. It is running in the background. It will never get killed unless and until you kill it or an admin kills it. A REST API which specifies interfaces that programs can use to talk to the daemon. So somebody will have to talk in a programmatic language to the daemon, and that is translated over at the API level, REST API level. This is transactional over the internet. If you want to talk to your applications over the internet, use API. So one application over the internet, another application over the internet, these two applications want to talk to each other. What will it use? It will use the safest and the most secured mode of communication between the two applications over the internet or two microservices through the REST API, transactional API. And the command line interface. This is the client. Actually, this is the client. This is with which you interact. Any questions? This is the Docker engine architecture. So the Docker workflow is, you know, Docker workflow is the client. As I told you, you will write some Docker commands, one line, single line commands, Docker build, Docker pull, Docker run. That will go to fetch. If you are saying Docker pull, that means you are pulling some image. This is the Docker registry or called the Docker hub. Let's say there are images already built for you, like the Nginx, like the Ubuntu, like the Redis, as we were discussing. So all these things are there already over on your Docker hub. The hub means like your GitHub, like your Bitbucket. This is a place where you can store your images. So you say Docker pull from the client and it goes through the daemon, it goes to your registry, it knows how to fetch it. And the Ubuntu, let's say this is the Ubuntu operating system, the Linux, you get it into your node or into this host, Docker host. And with the help of, so this image, you can put it into a container with the Docker build. And you can run the container, because once the image is inside the container, you can run the container. So you need only a single command. You see how easy it becomes. Did you install it? No, you got it from the Docker hub. Every other, you name it, you name Oracle. Yeah, Oracle is there. You name Windows operating system, you get it. You want Java application. Yeah, you just get it and put it into the container. Your Java application is running. Your Java, the compiler is running over here. And then you can put in your Java code, the source code. And therefore you can build an image on top of Java. You want Apache web server. Yeah, you put first of all Tomcat, Apache Tomcat, then install or get the image of Java into this. And then you deploy your Java application. So you can run this container, means you are running this application, your Java application. As simple as that. You want to have one MySQL server, which is a database, yeah, or a PostgreSQL. Okay, you get it from your Docker and so Docker hub and put it over into that container. That's all. So you have Java, you have your MySQL, so you can talk. Your application can talk, your Java application can talk to that database. How simple it becomes. So Docker workflow and Docker components. So now we are coming to the, the components. These are the nothing but the something like Docker file. You see a Docker file is there, which is an artifact, Docker artifact. You put in your instructions. I will come like this. You see, this is the cloud. On this, there is the Docker hub, which is a repository officially by the Docker company, which is kept in a cloud. So you can pull in the images and process this image inside a container. So you put that image layers, layer after layer. So you see image, base image, then you added Apache Tomcat, and then added Git. So image 1.0, image 1.2. So this is one big image, but of various layers within the container. So you have built a container with so many layers of image. So this may be Ubuntu. On top of that, this can be Apache. On top of that, there can be a Java application, and there can be an application which was built for Java. So let's say some Spring Boot application. Fine. So this is one container and one application. So you can run this Java application simply. You run, you can stop, you can delete your container. So what we learned is, first thing is the Docker hub. This is one component of the entire Docker ecosystem. And you see this Docker uses AUFS file system, a layered file system. Okay, this file system is especially meant for Docker, because Docker will use layers and layers for images to build that image. So first component is a Docker Hub, where it is nothing but a repository where you store your images. How do you store your source code? You use either GitHub or GitLab, isn't it? But those are all source code. Where will you store your image? You will store your image in the Docker Hub. You cannot store your source code over here. No Java files over here, but the Java image or Oracle image, any image. This is the image repository. Then we can come to Docker Engine. As we have already seen, Docker Engine is the heart of Docker ecosystem. It is responsible for managing your container runtimes. It works on top of operating system level. It utilizes the kernel of the underlying OS. So you have a Docker engine. Inside the container, you do not need a kernel. You can leverage the Docker engine. Docker engine will in turn, whatever the kernel it needs, it will go and exploit the underlying OS. That's all. Then the other component is Docker image. We have learned about Docker image. What is that? We continue with that. So the components and the container. After the Docker image is the container. A Docker container is a lightweight software environment. So you know that. Next comes the volume. As I said, the containers are ephemeral. You know what is ephemeral? You have a term called, sorry. You have a term called ephemeral. Ephemeral. Can anybody help me? Why? What is this term? What is called? I will say containers are ephemerals.
It's like it's not long lasting, it disappears.
Correct. Absolutely correct. This is called temporary. It is not long lasting, as you correctly said, temporary. So you can create your container. You can create your container as long as it is running in the memory. It is fine. But this container does not have any provision for storage. So you cannot store anything over here in the container. So what will happen is that if the container goes down, the container is very ephemeral. It can go down or it can drop or it can easily get deleted if you delete it. It is not very difficult to delete it or drop it or to stop it. The container is running, you can stop it. So immediately, whatever little storage, it has a default storage, but it's very, very less. Something was stored in that storage, it is gone as it dropped or deleted or stopped. Right? So that is called ephemeral. You say it is an ephemeral system. So an ephemeral system is not dependable. So for any persistence, you know, store. Storage. For storage, you need Docker volumes. It is like you know, the AWS S3 bucket. AWS S3 bucket. So a Docker volume. And when we learn about Kubernetes, Kubernetes will convert Kubernetes, we say K8s. Kubernetes will use the same concept of Docker volume, which is a persistent volume. It is like a store. It can give you a storage permanent. Even if the container drops out, the storage will remain. Okay, the Docker volume will remain unless and until you drop it. And Kubernetes converted that into the persistent volumes and persistent volume claims. The concept and the technology is the same. Are you getting me? So this is very important to understand the Docker volumes. Okay. So this is one of the components, very important component of Docker. And finally, we come to the just 1 minute. Yeah. So finally, we come to the Docker file, and Docker file is the artifact. Somebody was asking about artifact. This is an artifact. Can you see? I will not say this is a document. This is not a document in the real sense of the term. This is a Docker artifact. Some instructions will be there. Some declarative instructions will be there. Either written in a particular YAML format, in a format. You forget about YAML. Say, let's say it's a text file, but there are line to line, line by line instructions. So that instructions will be an artifact for Docker. So Docker can use this artifact to do something automatically. So for automation, you need some artifacts. Why do you do automation? Or how do you do the automation? You do the automation through some instructions which can be executed automatically one after the other. That is called the Docker file. And the higher version of Docker file is called the Docker Compose. So because Docker file, you can build one image with one Docker file. So if you want in a microservices environment, Docker came earlier before actually companies started to use microservice. So Docker file was fine. The instruction manuals or the deployment manuals which were given into to the operations team as Docker artifacts was fine. But gradually, when the number of microservices kept on rising, it was very difficult to write one Docker file for one image or microservice. So if there are hundreds of microservice, how many Docker files will you need to write? How many artifacts do you need to have for sustaining or maintaining or creating those 100 containers or 100 images? You have to write 100 Docker files. Is it good? Do you think it is not a nightmare for anyone maintaining those artifacts? It will be very difficult even for the development team to give 100 artifacts to the operations team is not at all a good method or a process. So came the Docker Compose. I'm not going into details, but the Docker Compose will replace the. So in having one Docker Compose file or artifact, you can invoke or you can create hundreds and hundreds of microservices. Just one file instead of having hundreds and hundreds of Docker files. That is the big difference. And also to connect between the microservices, it is very easy and simple. I will show you in a Docker Compose file. It is very simple to do it through the Docker Compose in one single file, whereas it will be very difficult for you to maintain the Docker volumes, the links between the microservices.
Quick one.
Is that
so in this slide, the first point on Docker file says it can be used to create custom containers. The last point says it can be used to build container images. Are we saying the same thing? Can we say containers
So
and
can
container
you say
images are the same thing?
no? Containers are lots. Say it's a package or it's a software package on which you put in your image, because that image cannot be run. Image is a static object. Image cannot run by its own. Image means your application. If you want to run that image, you need a container. So container is a different object and an image is a different object or a Docker component. And to make them work together, I will have another component called Docker file. So in which I can do manually to create an image, then put that image into a container and then run the container. I can do these 3 actions in one file, and that is Docker file. But that Docker file is also an object. Is that the question? Was that the question?
Yes, I
something
just wanted
else?
to make sure that there are two different things.
Yeah, exactly.
Okay.
They are 2 different things.
Okay. thank
Exactly.
you.
They are 2 different Docker objects. Yes. But yes, one cannot exist without the other. So a container cannot exist empty. You cannot have an empty container. There is no, as I told you, containers are ephemeral. A container has no meaning without an image. Okay, and also a image cannot exist, or rather has no meaning without a container. I mean, you cannot run a static image. And if you cannot run an image, what is the use? You want to run your Java application, so that application will only run if you put that into a container. That is containerization. You simply have to run that container. Yeah, so this is a hands-on. I thought I would be, but I don't know, Mr. Menon. Will I have some time to just demo, not to do it, build my demo from scratch? Just can I demo it? Do I have enough time?
What do you think, guys?
Yeah, I think you have enough time.
I will just demo
Yeah.
it. I will just demo it.
Sure.
Yeah.
Just yeah, it will be very good, because otherwise you will not be able to understand the whole thing, the story that we have built over the 2 days. Okay, so
Okay, before you move on that phase, let me answer one question which I have received couple of minutes before from Pradeep.
Please.
Yes, Pradeep, if you will have all of those PPT, this class recording, everything, if you are already registered for the DevOps Internship Program 2, because we divided it in 2 segments, 1 and 2. In 2, in the day 3 curriculum, you will find all of this. It is well segregated and well designed, so you can find it very easily. But to get that access, you just need to register. Hopefully you have registered. That's the reason you have joined. You just need to check in the website.
Yeah, sure, sir.
So can I go through it?
Yeah, sure, please.
So I will in a very short, because I do not have any intention that overnight you will learn everything. So I'm not going to do that as well. Just I'm giving an overview of the Docker Compose. I was saying that it's an artifact. It is called an artifact where you write some scripts, some instructions you are giving, but these are not programming way of doing programs. Like in Java program, you do Python programs or you do Perl programs. Okay, not that. It is very simple, like whatever you want, you state it. Yeah, in a definite format with a definite the way the keywords. Like the keywords for a Docker Compose artifact is the version, which version you are using. Services. Now, I'm not using a Docker file. In a Docker Compose, I can declare as many microservices that I want in one single Docker Compose YAML. So this is the file. I'm not going into details, but just saying that how many services do you think there are in this entire artifact? I just highlighted bold. I made it bold.
2.
2. Fantastic. I am very happy that just by looking at this, the structure is so user friendly that you can understand under service, you have one service called my web server, any name. And the other one is my DB server. So by basically there are two applications or two microservices. One is the web server, the web server, web application, and the other is the database application. So one web application is Nginx. Nginx is a very, very good your reverse proxy, as well as I will suggest you, please, before you go to Kubernetes, please have an understanding of reverse proxy. Okay, what is forward proxy and what is reverse proxy? Why do we need a reverse proxy? Just for a hint, you can look at that in Google. So Nginx is one of the very important, very famous, very popular reverse proxy, which can also work as a load balancer, as I told you. Anyway, in this case, I'm using Nginx web server. I'm using this as a web server. OK. And I'm using another service called, I can name any service. You can give your name as well. But actually, which matters is what is that image? That image is MySQL. MySQL is a database. Nginx is a web server. Now, where I am getting this image from, I do not need to mention anything. Docker knows very well. Through this artifact, the Docker daemon will know to fetch this Nginx image from Docker Hub. Docker Hub, as we understood, is one of the components of Docker ecosystem. Clear? And then we have given this sort of parameters, or these are the arguments of this service, that this is the image, that this should always restart. This will be started on a port, and I am giving a port mapping of 80. So the Nginx will, so port mapping of 8080. Nginx container, the Nginx is an image, and it will be put inside the container, but the container will need a port on which this service will run. This is a service, so it will be running on port 80. But from outside, I cannot access the container for the security reasons. So I have a mapping of 8080. So you can give it 81 or 82 if that is available. So if nobody is using this 8080, you can use it for your external application. So you will externally access this container from outside using 8080. I will show you. Now, this is my database server. I cannot access from outside for the security reasons. I cannot access MySQL database. Who will access it? My web server will, this application will access the database server, not you from outside. You have to first connect to your Nginx. Nginx will do internally connect to this thing. And I am making a link. I'm linking this Nginx to my database server. This Nginx will be only up when the database server is up. If your database server is not up, you cannot make this Nginx up and running. So all these dependencies. So as we said, the dependencies and the links are established. How easily within one line of code you can do that. And of course, to get inside MySQL, you need a password. You cannot go with an empty password. And the port, the default port for the container for this database service is 3306. This is the MySQL database port. Each and every service will have its own port. Like for your Apache HTTP server, it is port 80. For Nginx web server, it is port 80. For SSH, it is port 22. So each of these services will have their own individual ports. Anyway, because I am not mapping anything external, so I will not give, because this is my security. I have to access 3306, and the 3306 can only be linked by this application. Nginx can only connect to this. Anyway, and I have declared a database volume. Here there is also a volume, but this is a file system bind mount, and this is a temp fs. Oh, these are all things that we need to learn in our session, but this is a Docker volume. This is also a Docker volume. Now I am coming out from this. I will go. You see, I will just demo this thing. I have already created a Docker machine, okay, with the name DevOps Internship Docker, and this is an EC2 instance on AWS Cloud. I have made it running where I have installed. So I have also connected over SSH. I have connected. Sorry, let me do it again. So this is my IP address. I will go over here. I will use this. I will open this. So I have logged into my EC2 instance. I will make it sure that my Docker is running. So I know my Docker is running. So the Docker engine, the daemon, okay, it is running in the background. So ps -ef grep. You see the Docker daemon is running, Docker D. It is running in the background. So my Docker is running. Now what I will do, I have a folder. I have also installed Docker Compose. Docker Compose is also installed. So it is the same version as Docker 1.29.2. And once I have done that, I have a compose file, the same compose file that we have seen in our this one, the same compose file. OK, I've written this, and this is my Docker volume. Since I have already run it, so I can go there. I will say Docker compose. Sorry, up. It is so easy, just one command up and run it in the background as a daemon. So what it is doing, it is fetching the MySQL database from where? From the library, from which library? From the Docker Hub. This is an image. This is the latest version of MySQL. So an image, an application is getting downloaded from the Docker Hub. Everything is done by Docker container. That is the container D or Docker daemon. Now it is that my web server, which is nothing but the, yeah, we are doing the Tomcat, sorry, not the Nginx. Yeah, Tomcat web server. So let me verify. Vi Docker compose YAML. Yes, I am using Tomcat. I'm actually downloading Tomcat instead of Nginx. So I will rectify this. I will not rectify. I will just, instead of Nginx, I will make it Tomcat. Anyway, the same, the rest remains the same. So I have a port mapping of 81828090 against 8080. Remember, Tomcat uses the port 8080. So there is a mapping, external mapping of 818280. I will run this from outside with this mapping of 81 port. And it will connect to the DB server. There is a link and all the stuff. I will go back. And what did we see? That after it had, first it is going to load the MySQL because there is a dependency. First, the MySQL was loaded, downloaded. Then the Tomcat was downloaded. That was the dependency. And once it has downloaded the image of Tomcat, it has created the service, the microservice. It is called DC test my DB server 1 and my web server 1. So this is the name of the containers. Now, how do I know that the container is running? Docker PS. So this is the container, but it is a bit clumsy. So I can say Docker compose PS. So what it is going to give me is the name of the container, the internal command on which the container is running, what is the state, what is the port mapping. So the DB server, the database server, which is the MySQL, is having the entry point which is running with MySQL. So don't worry about this. It is the state is up and the port mapping is 3306 against 3306. So I cannot access it directly from the outside. Another is this container having an image of what? Image of Tomcat, Catalina server to Tomcat server.
So I have a
And
question.
yeah.
Yeah, actually, I'm always confused about the two command Docker, like the first one you just did Docker PS, and then at the bottom you did Docker compose. What's the difference between those two commands, please?
There is no difference. There is no difference because I am going to, this is also a Docker command. This is also a Docker command, but because this is also giving a list of the containers. See, the container names are the same. DC test my web server, DC test my DB server, but it is giving me the same information in a more organized way. Either you can go for Docker PS or Docker Compose PS.
So there are no difference in terms of configuration when to use Docker Compose and Docker. Okay.
No, not at all. Not at all. Not at all. You see the port mappings 8090 versus 8080. Then 882 versus 8080, then 81 versus 808. So here also you will see 81 versus 8080, 82 versus 8080, 8090 versus 8080. Same thing. Now with this, I will see that they hello.
What's the meaning of PS?
PS means the processes, the container processes. PS stands for processes or the containers, container processes running in the background. So this is your application is running. Your container running means your application within the container, the image. Now I think you are going, you are getting a bit of idea of Docker, isn't it? I'm very happy for that because you are asking good questions. So this, if it is not running in the background, what will happen is that Docker PS all. Now this is up for 4 minutes. Last 4 minutes is up. It is not giving the details, but it is also saying up. It is up. And because it is up, and let me see where it is the websites, because under the websites, the Tomcat, the web folder has been mounted, and I am having some index file. First, what I will do, I will make a command like, first of all, let me run this. I will go into this. What is my public IP address of the server? Where is this container running? In this server, right? So I will go saying HTTP, because this is an HTTP server, I have not installed the SSL certificates. So it is not a secured site, but anyway, it is, I know it's my site. So what is the IP address? This is the IP address. And what is the port on which you want to run it? Externally. Can you run the Tomcat server with 8080? So 8080 will not allow, because 8080 is the container port. I cannot directly access the container port for security reasons. So what did I do? I have given the mapping. I have given the mapping as one of the mapping, external mapping is 8090 or 82 or 81. So I can use any one of them. Let me use 8090. Right now, I'm saying, yeah, it is going to hit that Apache website or the web folder, but it is not finding the index HTML. So it is getting that status 404, that file not found. Okay, so what I do, I know this is the index.html, and I will just rename it to index.html. Sorry, sudo. Let me clear the screen. So ll sudo means this thing. Copy index.html to index. Once I give index.html, it knows this is the index page. So the first page, landing page. So what I will do, I will go over here. I simply refresh this. Do you see the Apache homepage has come? I mean, you can go and click on this Tomcat homepage. Are you finding? Nice. How it is possible? It is possible because your container with that Apache web server is running. Are you getting me?
Yes.
Docker Compose, what? PS. So you see this is up. So sorry, this one is up. Your Catalina server, which is the Tomcat server, and I have used 8090. Can I use 82? So let me open up this one. What is my IP address? I go over here and I pick up my IP address and go over here. I say HTTP. I may not give HTTP. This, and now I'm going to use 82. Will it give me the same result as this one? Yes. Why not? This. I again go over here. What is the other one? Other mapping? Isn't it
81.
82? 81. Thank you. And I say 81. You see, all these are working fine. Now, what I do, suddenly I thought maybe I have an application. So what I will do, I have an application for Kalkey. Kalkey, I want to display my Kalkey page. So I will change a bit. So what I do is copying this one as this one. Okay. Sorry. I am doing, see, once my container is running, now I'm the king. I can do whatever. I go there and I'm now going to again say HTTP. What is my IP address? Is that IP address? No. I will copy again. I will start with 8090. What will happen now? Will the Apache page come or the Kalkey page come?
Okay.
Kalkey. Isn't it good?
Where is this index.html file defined? Is it in the YAML?
Yes, because I have prepared this demo for you. Yes, this is the index.html. If you are interested, then you can go for this and see the small application. This is a simple HTML file, nothing else.
So
See, welcome to Kalkey training. And there is an image of online JPEG. Welcome this. So this is welcome to Kalkey training with a logo of Kalkey. So the logo of Kalkey. So this is
Okay, my
my
question
small.
is it mentioned in the Docker Compose YAML file?
No. So very good question. Fantastic. So what is the Docker Compose YAML file doing? Docker Compose YAML file is building up the service, which is vi docker. You see, it is installing, or rather getting the Tomcat web server from the Docker Hub and only mapping the relevant ports. It has started the service on which port? On port 8080. And you have mapped external ports. Then it has declared this volume where you have got this web folder of Tomcat mounted over the website. So that websites is a bind mount. Bind mount means this is bound over into your physical file system of your folder in your system, Linux system. But this is something which is the volume, because see, database will have the data persisted. So you need a more secure data volume. This will not be mounted simply because this mount is a dangerous mount. It is not very secure. Somebody can go and delete all these things or modify this. But here nobody can go to this because it is protected by tempfs. It is Docker maintained volume. This is also a Docker maintained volume, but this is hidden from the application. Nobody can look into that.
Okay, so
I have a question. So under the compose file, could you also give the path of the HTML?
Yes, I have given. The website is my path, because this is where the the web folder of Tomcat web apps. If you know about Tomcat, then you will understand that this is the web folder, like in your Apache. In Apache, it is /var/www/html. Various applications will have their own way of handling the web folder, the web page. And the first web page is always the index.html. So what I'm doing, see, this is maintained inside the container because your container has this particular service or application. But here, this is in my file system. If you go and look into it, where am I? These websites have been created. Can you see this is root? So when I executed my Docker Compose, when I made Docker Compose up -d, then this website was created. And I have, because it's a demo, I have kept all these files.
Okay, this makes sense now. So the index.html is on that part, in the Docker Compose.
This is the part that you
makes sense.
Correct, very correct. This you are actually, you have got the essence.
So if you are explaining, like when you said about the human body, remember, like if let's say you're having
Yeah, sorry. Are you speaking? Hello? Hello?
Probably our network went bad.
So is it who's speaking? Cephas? James?
Yeah, yes, I said probably her network went bad.
Oh, okay. Maybe the connection has gone wrong. Somebody was asking a question. Very good question.
I was asking, sorry, can you hear me now?
Yeah, I can hear you now.
I was asking, like, can you please explain using something like, you remember when we were doing the containers, you were talking about the human body and how if your head is thick, you
yes.
cannot completely shut it down. So in this
Okay.
instance, I'm thinking, so when you are mapping the HTML,
Yeah.
I can't really picture it like.
No, that example I have taken for a monolithic application. Remember,
Yeah.
when your entire body is one application. So
Yeah.
if you try to something happened with your hand, some right hand, there is a fracture. So will you be able to simply cut out your right hand and then do some plastering and then fit it back? No.
No.
You have to take the entire structure. That means you have to go to hospital. You have to plaster it, take some medicine, and the entire body. Then you have to give it a rest, and then that means you have shut down yourself. And then when you recover, you make yourself up. That means you go to office, then do the normal core. So that was a monolithic. Here, you see, I was replacing the application layer. Something like that I have put in my application instead of the Apache or the Tomcat application. Okay, I could do it easily because it's a microservice application. Without stopping, did I stop the container? If I so suppose if I say Docker compose down, I'm making the entire all the containers down. So what did it down? It stopped the service, DB service, the web service. Then it removed the container, both the containers, and it shut down the network. All these things it did. So if I go back, and now I try to refresh this, will it work?
No.
No, because the container is down, your application is down, unable to connect. I will do it immediately. What I will do? I will say up -D. So all your services are up. In one shot, I again refresh it. Do you see? It has come back. How fast? How efficient?
Okay, thank you.
Thank you. So this much for today. I think we have, like for every other sessions, we have exceeded the time today as well, but it's okay. I'm happy with it. If you can learn a bit.
Hello.
Hello.
Is it too late to ask a quick question?
No.
Okay, thank you.
Please ask. Go ahead.
Yeah, I understand the demo, and I understand that the definition file was about the service, right?
Yes.
So I assume that previously you did a deployment service when you launched the containers, right?
Yes.
And you just have to now launch the service on this session.
Yeah, sorry. Yeah, I already built that containers and everything. I done the scratch work.
Okay. Okay, so that's why I was a little bit confused when I was looking at the definition file. Okay, thank you.
Because otherwise it would take time.
Exactly. I understand. Now I have another question. Can we go on the website of the school website? Because I always have trouble to look at, to see the recording and the slices. If you can show us, where to get the recording of the class.
Okay, Mr. Menon, are you there?
Is it okay if you can? Yeah. Is it okay? Can you share your screen? Fonuka?
Oh, my screen?
No, Fonuka.
Okay.
Oh, you mean me?
Yeah. Is it possible?
Sure. Let me see.
So let me stop my sharing.
Yeah. You are not registered, right? For this
I'm
one,
sorry.
you are not registered yet.
Yes, I am.
So can you log in?
Sure. Let me.
Until training, just log in. Go to your profile. Internship program 2. Continue.
Or you need to press continue?
Yes. Last 2 days video is here.
Oh my God. Okay. Oh my goodness. Okay, thank you.
If you
It's
scroll
because
down,
the other class we have,
I think Mr. Menon, if
Yeah.
you can also in that group, you can put in that process of maybe many, it will help many.
what I'll do, I will ask
Just
our
do
team,
a video.
yes, to cut it this portion and post it over there, because fortunately enough we are that Phonuka demonstrate very well that how to retrieve those videos.
Correct.
Thank you
correct,
so
correct.
much.
Thank you. Thank you. Thank you.
Now I do have some announcement. Today around evening we do have a cybersecurity session. Those like I just saw Phonuka, you have also registered for that. Please join if you have a time. The session will be taken by our beloved and respected trainer, Mr. Karthik, and that is one announcement. I am coming back to another point where
And I will tell you one thing, we are really privileged to have him as a trainer with us. You know, is such a brilliant guy, and you will understand when you join.
Yes. Now, Joy, you have asked about the DevOps job market future. So so this is LinkedIn, and this is market.us. It is their predictions. Can you see my screen?
Yes, sir.
Yeah,
Yes,
we
sir.
can see your
Yes.
screen.
Yes.
Yeah. So today, the global DevOps market valuation is 13.2 billion. In 32, it will be reach 57.3 billion. So it will 4 or 5 times it will increase.
It is in the
So
ascendancy. Yeah.
yes, and it is not only one. I have some more. Right now it is showing 2022 is $8.29 billion market cap. So always remember, job opening volume of your job is depend upon the market size of this particular technology. So right now market size is $8.29 billion, but in by 2029 it will reach 40 billion dollar, and it is increasing exponentially, because you can see it is not a linear straight line. If it is a straight line, it will reach like here, but it is exponentially it is growing. So it is growing very fast, and 20.5% is growing.
And to remember, this is with the competition that AI is providing.
Yes.
Against the competition.
Because after a few maybe months or a year, AI will incorporated with DevOps.
Exactly.
So
this is the right time to learn DevOps, because the market is after 2 years maybe, then it will, if you are not into DevOps, you have missed the bus.
Yes, true.
I have a quick question. So for DevSecOps and DevOps, do you have to have the background of DevOps engineer to get into DevSecOps?
Yes, it's not like you have to have the background, but now think you are hired to secure some infrastructure, but if you don't know what you are securing, you will not give your full potential to the company, right? To secure, before security comes, you need to understand what you are going to secure. So in that point of view, if you know DevOps and cybersecurity, by default you are a DevSecOps engineer.
So it is like you will not be admitted to any university if you have not passed the high school.
Okay, it's like for me, I don't have any background in DevOps. I mean, I've been taking the courses, but not actually work. But now I'm doing DevOps.
That will not going to affect any way, because again, in US the job market is so beautiful that they are not going to judge you based on your previous experience or previous educational degree. They will ask you some simple question based on their project work, and if you have like if you can showcase that you can understand the issues and you can suggest some of the remedies or method or troubleshooting method, they'll consider you as a good fit. So to join as a DevSecOps, because DevSecOps is right now one of the high-paying job in US market. Cisco is paying $225,000 per annum as a mid senior. Not I am talking about VP or any C-suite
CIO,
yeah,
or
C-suite positions. Yeah. So normal cybersecurity experts, Cisco is giving average salary for 225K per annum. Now, because why it is so demand, the salary is so high, because demand is very high, but supply is not that much. So salary is varied from demand and supply. In the job market, there are too many opening, but very few reliable DevSecOps engineer is there. So that's the reason.
Okay, yeah, because I'm in the class with Mr. Kartik. So the way I'm understanding it now, even though I do the DevSecOps, I still have to focus on DevOps to learn more.
You have two options. You can learn while you are working. That is a one way. Yeah, definitely. Or else you can prepare yourself before facing those your team members or before standing the firing squad. So, but there are I know plenty people. Those are not at all IT background, but they are working as a DevSecOps engineer, doing classes with us, and definitely their capacity and interest is off the chart. And in the other hand, I have seen people who have done cybersecurity or DevOps classes, then they shifted gradually, and that took little time to other from cybersecurity to DevSecOps domain or DevOps to DevSecOps domain. DevSecOps is not a domain; it is like applications of these two. Now another announcement. Charlie, right? You were.
Yes, sir. Yes.
So how is your cybersecurity class going on? Is it good?
It's going well. Yes. So I'm learning a lot. It's going well.
Perfect. Now our DevOps classes is supposed to start last Friday, but unfortunately some of our classes extended, so we could not start last Friday. Hopefully we are going to start this Tuesday. Hopefully like 199% confirm, because our trainer got freed, thanks to Mr. Devashish, and he can start from this Tuesday. So those students are very new and want to join. Feel free to ping us, because there is a one coupon by which you can. This coupon is valid for only today. You can utilize it and you will get $50 off with that. I cannot paste it here because it has become public. Because So if you are interested to join our DevOps evening batch, which is going to start every week, Monday to Friday, 7:30 p.m. Central Time for next 2.5 hours, and for next 45 business days, 40 like 1.5 months. So yeah, if you want to enroll for these classes, ping me to get that coupon. What the time of the evening, the cyber security internship? Cyber security internship, it is going to be 8:30 p.m. Central Time. So ping BDME, are you in the WhatsApp group?
Hello, sir.
Yeah, are you in the WhatsApp group?
Oh yeah, absolutely.
Then I will share the meeting link over there.
Okay, thank you.
Joy, if you are interested to enroll for our DevOps classes, ping in the WhatsApp number or in the group. One of our team member will ping you, and if you have any doubt, they are going to clarify. You can, if you have any doubt, you can ask the question here as well. So thank you all. I think we had some internet issues, but because your encouragement, we are able to continue. Thanks all of you. And at the end, thank you, Mr. Devashish, for your such insightful session on Docker.
Yeah, I would like to thank all of you for encouraging me within all these technical hiccups. So to continue, that was a great thing. I enjoyed really. It inspired me. Thank you.
And today's class was a good hands-on, and I think we had a discussion with BDME and other some students. I think Vaughn was there that day about the how much ratio we'll put the hands-on part and the theoretical part. So I think today we have created that exact ratio. So students they started interacting with us, and thank you, and please guide us if you feel that and suggest us if you feel that the theoretical part is becoming more and hands-on part is becoming less. Feel free to ping us, guide us, so we can redesign our internship program in that way, because the biggest hurdle we are facing, we need to cover up like a 1 or 2 week session in 2 hours. So we need to and we do have students with IT background, we do have attendees without IT background, so we need to make sure that it should be acceptable for for both of them. Thank you, Vidimi, for your affirmation. Yeah, well, I think we can work on that in future as well. Thank you.
Thank you all. Thanks a lot.
Thank you.
Thank you, sir. That was a great session.